65 million years ago, Earth appeared to be unstoppable. Dinosaurs ruled the land, the oceans were vibrant, and the sky above was serene. However, on a normal night, that peacefulness was already disappearing. Imagine yourself standing in North America a long time ago, gazing skyward. Initially, you may observe what appears to be a bright star, but this light is not correct. It becomes brighter, bigger, weird, and as time passes, it becomes evident that it is not hanging in the sky at all. It is finally here. What was speeding toward Earth would strike at what is now the Gulf of Mexico on the Yucatan Peninsula. This would result in the tragedy that ended the dinosaur era. Researchers believe they have created a more complete picture of that day's history by combining recovered Chicxulub rock strata, high-resolution images, microscopy, CT imaging, and magnetic data. And what they discovered was far frightening than what they had heard previously. The asteroid did not simply fall from the sky. It tore through Earth's atmosphere like a bullet through paper. This wasn't simply a meteorite burning up. It was a mountain-sized boulder traveling at speeds of over 45,000 miles per hour, which is difficult to comprehend. Smaller space rocks break apart in the air, but this massive asteroid, which was 7 to 50 miles broad, smashed right into the atmosphere with unimaginable force. When it eventually collided with Earth, it left more than simply a crater. The collision was so powerful that it caused shock waves all around the Earth and immediately converted everything in its path into gas. The asteroid collided with the shallow sea over what is now the Yucatan Peninsula, causing devastation for the first time. That's when the force was so powerful that even the air couldn't escape. When the asteroid crashed, the pressure was so tremendous that it caused the Earth's surface to ripple. Consider how hard a cannonball hits the water. Consider how badly it hits the entire globe. The first splash ejected debris in all directions, and the Earth's surface bounced back up, rising higher than Mount Everest in just a few seconds. It wasn't simply a rock, it was a natural power, one that produced more energy than 1 billion Hiroshima nuclear bombs. The explosion was so powerful that it caused the air temperature to rise swiftly, resulting in a fireball that incinerated everything in its path. When the rock dropped deeper into the Earth, shock waves spread, generating massive earthquakes that could be felt throughout all continents. But the devastation did not end there. When the asteroid hit, it ejected billions of tons of debris into the atmosphere. Some of this debris was so large that it came back to Earth as tektites, glass-like shards at breakneck speed. Some fragments were as large as buses and others as little as pebbles, but they all have the same lethal power. The tektites set fire to entire trees as they fell because they scraped against the air. This searing downpour ignited a fire that spread across the world. Some people believe that the heat from these embers made the Earth's surface feel like an oven ready to bake. When the debris fell, it ignited flames, destroying entire ecosystems. But the flames were not the only problem. Tsunamis as tall as skyscrapers smashed coastlines within hours. Waves as high as 600 feet swept throughout the southern United States and Mexico, altering river courses and flooding tens of miles inland. This was simply the beginning. The tsunami waves struck every beach, from the United States to Europe, Africa, and even the Mediterranean. While the fires and waves were wreaking havoc, another disaster was unfolding. Massive earthquakes were shaking the Earth due to the shock waves. The Earth trembled on every continent, and the entire planet appeared to be shaking in response to the chaos. However, this was only the first 15 hours after the collision. The worst was yet to come. Following the initial explosions, Earth descended into even greater disorder. For the next 2 to 3 years, the Earth would be covered in a thick black soot layer. This layer was composed of oil and sulfur that had been melted and released into the atmosphere. This layer blocked 90% of the sunlight, causing the entire world to freeze over for a long time. The world's temperatures fell by an average of 50 degrees, and it was always winter. The storm clouds that formed after the accident began to shower acid rain, filling the previously pristine skies. The oceans became more acidic and the land drier. The extreme cold killed or burned the majority of the world's flora, and the few that remained could not survive without sunlight. The global freeze lasted years, and the consequences were devastating. The food chain snapped. Species that could not adapt or find safety in water or underground died. Dinosaurs, who had governed the Earth for millions of years, suddenly found themselves in an unlivable environment. And while life on Earth slowly died beneath this layer of ruins, the few individuals who survived faced an equally bleak future. But where did this beast come from? According to researchers that used supercomputers, the Chicxulub asteroid most likely originated in the Oort cloud, a vast freezing realm at the outside of our solar system. It could have been a much larger comet that split apart due to Jupiter's gravity. One of those pieces then hit Earth. The science is always evolving, but the Chicxulub disaster demonstrates that objects from the Oort cloud can cross Earth's orbit and strike the planet, wreaking havoc every 250 to 730 million years. This asteroid might have been unique, but the danger is real, and it might happen again. And everyone wonders if something like this will happen again. In 2021, NASA reported that an asteroid named 4660 Nereus passed within 3.8 million kilometers from Earth. That may seem far, but in the larger scheme of things, it is not. If it deviates even a little from its intended path, it could collide with Earth. Astronomers monitor thousands of near-Earth objects, but despite all our technology, we still don't know how to prevent a large asteroid from striking Earth. NASA's DART experiment, which is testing methods to shift the route of asteroids, is only the beginning. But moving a large asteroid off track, one that is 10 kilometers or larger, is a very different matter. We've made it through before. Will we be as lucky the next time? Will science give us the answers we need? Or will Earth face another unavoidable cosmic disaster? Please leave a comment below and tell us what you think. And don't forget to come back here when we learn more about the universe's mysteries and potential perils. Thank you for watching, and remember to subscribe for more entertaining videos. Until next time.